So let's make sure we understand how vectors add together before we move on to some harder problems. So in this case, you see steps: resolve all vectors into components. 2, add all the x components together to find vx and all the overall vx, and add all the y components together to find the overall vy. Then we can determine the magnitude and direction of v, because once we have the overall x and the overall y, it just forms a right-angled triangle. We can use Pythagorean theorem as well as trigonometry to find the magnitude and direction. So there's no numbers for this one, just an example. So let's say we had a vector. Let's get the arrow tool actually. So I'm going to draw a section. Then from there, we're going to have a second vector just going up. I'll make that say length. Okay. So I have two vectors. The resultant vector is always if we draw a line from the beginning to the very end. Okay, so it would be a line from the beginning all the way to the end. Now, of course, we can add some arrows to this as well. So we have our first vector, our second vector, so v1, v2, and a resultant vector in red. Now if I look at v1, it has an x component and a y component, so I can actually draw that in. So there's my v1x. From here, this is my y component of my first vector, so this is v1y. Now vector 2, we say, okay, this is going to be our v2x. If we go straight up, this is going to be v2y. It can get a little crowded, so a nice big diagram can be very beneficial to you. And this is our VR, so our resultant vector that we're looking at today. So I can see then, if I draw this VR again, so as to say that's our VR, looks actually the same. Here's VR. Well, we can see that if I just were to take the x components, there's v1x and v2x. This length here, the x component of VR is just simply the addition of v1x plus v2x. That is the magnitude of that vector. Right here, this is just going to be v1y plus v2y. And now that we have this very simple triangle, we just use Pythagorean theorem. X squared plus y squared equals our hypotenuse squared. And inverse tan, we can find the overall direction of this final vector. Another cool thing about vectors is order does not matter when adding two vectors together. So notice in this case, I did v1 plus v2. The question is, what would happen if I did v2 plus vy? Let's draw it in green. If I started with v2 right here, v2 was 1.5. And if I then were to add gets the same final destination. So v1 plus v2 is the same as v2 plus v1.